the integration by parts. So the integration by parts, what is the formula? So the formula actually is UdV equal to what? Equal to UV minus VdU. Yeah? So this is the integration by parts. Okay? Integration by parts. And now, so we use the integration by parts. We need to how to choose the U and how to choose V. Okay? So choose U actually is we have experience means use L-I-A-T-E, yeah? L-I-A-T-E. So here means what? So L-U, the L means the logical magic, okay? Logical magic, second I, okay? Second I means that the inverse logical magic, and the A means the algebraic, okay? And the D means what? Trigonometric, and the E means the exponential, okay? Exponential. So here, and we introduce at the end of the last class, we introduce the antiderivative of in this form, okay? Fx is times px dx, okay? Fx times px dx. Here px is a potential, okay? Here px is a potential. No, polynomial, okay? Here px is a polynomial. Is a polynomial. So for this integral, okay, for this integral actually we have a formula. Actually, this formula is comes from the integration by parts, okay. So here, so first means what? Means the repeat sectionable, okay. Substitution. So the first column, okay. So the second column means the repeat the integration, okay. The integration. So here the repeat sectionable means the derivative about the px, okay, about px. So here is px, okay. And repeat, so repeat sectionable, so here means p prime, okay? P prime and p prime, okay? And p prime x. So go up, okay? Go up. Because p is a polynomial, okay? P is a polynomial, so here means that we will find a derivative will equal to 0, okay? So we are equal to 0. So this the first column is the repeated decimation, okay? So the second is the repeated integration. So integration about what? About fx, okay? About fx. So here, so the first here is fx. So the second here, the second function is capital F1, okay? Capital F1 actually is the antiderivative of fx, okay? So, and capital F2x actually is the antiderivative of capital F1, okay? So, antiderivative of capital F1 and capital F3, okay? Capital F3x actually is the antiderivative of capital F2, okay? Capital F2x dx. So go on, and now for the first here times what? Times the first, okay? The first times which? Times capital F1 times capital F1, and the second p prime, okay? The second p prime times capital F2, okay? Times F2. And p prime, okay? P prime times what? Times f3, okay? Times f3. So go on, okay? So the first here is plus. The second is negative. So the third is plus, okay? Plus sign. So go on, okay?
Yes.
So here means actually, so here actually means what? So here actually means the indefinite integral of fx times gx or times px actually equal to what? Actually equal to px times f1, capital f1x, here is plus, okay? And minus p prime x times capital F2x, okay? Times capital F2x and plus p prime x times F3x, okay? So go on, okay, go on. So this is I introduced here at the end of the last class, okay? So now I give an examination. Oh no, I give an example. Oh, I'm sorry. So I give an example for this example. So the antiderivative of x squared times the square root of x minus 1 dx. Okay, for this one, okay. For this one, actually, we introduced this example, okay, and we use the u substitution. So means let u equal to x minus 1, and then you can use the u substitution. You can find the antiderivative of this function, okay. But now here we can see here x squared actually is a polynomial, yeah.
Yes.
So here is the polynomial times another function, so we can use this method, okay? We can use this method. So here, the first here means the repeat fractional. Differentiation, okay? So the first column is the repeated differentiation. So the second means the repeat integral, okay? So integral. So here, the first here is x squared, okay? So the second means x squared prime, okay? So x squared prime is what?
2x.
Is 2x. And go on, okay? 2x prime is what? 2, yeah? And go on, 2 prime.
0.
0, yeah? So here is 0. So we finish at here, okay? At here, because here is 0, so. And now, here is the repeated integral. So here, the first here is the antiderivative of x minus 1, okay? So this is the first.
Yes.
So the second here is capital F1x. Capital F1x actually is the antiderivative of the square root of x minus 1 dx. So now we need to find the antiderivative of square root of x minus 1 is what? So here actually is x minus 1 half power dx. Yeah? Dx. So now we let u equal to x minus 1, okay? So we let u equal to x minus 1. So du dx equal to what? Du dx, u equal to x minus 1. So du dx actually is the derivative of x minus 1, yeah? So here is what? Here is 1, yeah? So here means du equal to dx, okay?
Yeah.
So here means du equal to dx. So from here, actually here is the antiderivative of u 1 half power dx equal to du. So here is du, okay? Here is du. So here is u 1 half power antiderivative. So here actually is u 1 half power plus 1 half power plus 1, okay?
Yeah.
So here should plus a constant c, okay? a constant c. So here actually it is equal to 1 by 1/2 plus 1. So 3 by 2, 1 by 3 by 2. So 2 by 3, 2 by 3, and u 3 by 2 power. U equal to x minus 1. So here is x minus 1, 3 by 2 power, plus a constant c. Okay, plus a constant c. So here means f1 equal to here. But here actually we just need to find antiderivative. Okay, so here we just this function. Okay, we just this function. So here means f1 equal to what? So here I write it here. Okay, so f1 equal to 2 by 3 times x minus 1, 3 by 2 power, 3 by 2 power. Okay. So here is f1. So we have f1. So we need to go on. Okay, we need to find capital F2. Okay, capital F2. So here f2 equal to what? f2x. Okay, f2x actually is antiderivative of capital F1. Yeah.
Yes.
Capital F1. So here is capital. So here is antiderivative of 2 by 3. Here is x minus 1. Here is 3 by 2 power dx. Okay. So now we need to find this antiderivative. Okay. So 2 by 3 is a constant. The move through the integral sign. So here is 2 by 3 antiderivative. Okay. So it's the same. We use the u substitution. So we let u equal to x minus 1. We let u equal to x minus 1. So here we have du equal to dx. So here actually is 2 by 3. So here is antiderivative of u 3 by 2 power du. Okay. So here for the antiderivative of this function actually is what? Is 2 by 3. Here is u 3 by 2 power plus 1 by 3 by 2 power plus 1. Okay. So here should do plus a constant c. Okay, but we just find one antiderivative. Okay, so here this function. So this function here is 3 by 2 plus 1. So it's 5 by 2. Okay, 5 by 2, 1 by 5 by 2. So 1 by 5 by 2. So here is 2 by 5. Okay, 2 by 5. So here is u to the 3 by 2 plus 1. So u to the power 5 by 2. Okay, u equal to what? U equal to x minus 1. So here is x minus 1, 5 by 2 power. Okay, so here is what? So here is 2 times 2, 4. Here is 15. And here is x minus 1, 5 by 2 power. Okay, so here means the second function. Okay, so the second function capital F2 actually is what? Actually is this function. Okay, so here is 4 by 15 times x minus 1, 5 by 2 power. Okay, 5 by 2 power. So this is capital F2. Okay, capital F2. So here we need to go on. Okay, capital F3. Capital F3. So here capital F3 x actually equal to the antiderivative of F2. Okay, F2. So here is the antiderivative of F2x dx. Okay. So here F2 is this function. Okay. So here actually is antiderivative of 4 by 15. And then here is x minus 1. Here is 5 by 2 power dx. Okay, dx. So here 4 by 15 is a constant, moves through the integral sign. So here is 4 by 15 times antiderivative. Okay. So here is the same. We use the u substitution. We let u equal to x minus 1. U equal to x minus 1. So So here actually is 4 by 15. So here is u to the power 5 by 2 du and du. So here, so we need to find any derivative of this function. So here actually is 4 by 15. So here is u 5 by 2 plus 1. Here is 5 by 2 plus 1. Okay. So here 5 by 2 plus 1. 5 by 2, so here is 7 by 2, okay?
Yeah.
So 1 by 7 by 2, so 2 by 7, okay? So here actually is 5 by times 2 by 7, okay? 2 by 7, and here is u is x minus 1, so x minus 1, 7 by 2 power, okay? So the result actually should be 8 by 105, okay?
Yeah.
105 x minus 1, 7 by 2 power, okay? So this should be F3, okay?
Yep.
So F3 equal to 5 or 8 by 105 x minus 1, 7 by 2 power, okay? So here now let's see here F3, okay? Because this one is 0, okay? So this one is 0, so here we compute F3, okay? We do not need to compute F4. Because here we can see, follow this rule, okay? Follow this rule. X squared times what? X squared times F1, yeah?
Yeah.
So here is F squared times F1. So 2x times F2, yeah? So 2x times F2 and 2 times what? 2 times F3, okay? And 0 times what? 0 actually should times F4, yeah?
Yeah.
Because here is 0, okay? So, because 0 times any number is 0, yeah? So here we do not need to compute F4, okay?
Yeah.
So here, since the first here is the sign is plus, the second is minus, so the third is plus. So the result actually should tell us that the antiderivative of x squared times the square root of x minus 1 px actually equal to x squared times f1. F1 is this function, okay? So it is 3 by 2 or 2 by 3 x minus 1, 3 by 2 power. So this is the first, okay? The second is 2x times this function, okay? 2x times this function, so here is minus, okay? So here is minus 2x times this function, so it's 8 by 15, 8 by 15 x times x minus 1, 5 by 2 power, okay? 5 by 2 power. So this is the second. So the third is 2 times this function, okay? 2 times this function, so here is plus. So here is plus 2 times, so here is 16 by 105. So here is x minus 1, 7 by 2 power, okay? So this is the result, okay? So here is the result. Here is the result. So remember, okay, remember. So this method, okay, this method just vivid, okay, just vivid for this form, okay. For this form, here a function times a polynomial, okay. A function times a polynomial, okay. So just this method, just vivid, okay, just vivid for this form, okay. A function times a polynomial. So this is this part, okay, this part. Now, today we will introduce 8.3 or 8.2 and 8.3, okay?
Yeah.
So now let's see pages 379, okay? Today we will introduce 8.2 and 8.3, okay? 8.2 and 8.3. So L.2, okay, L.2 actually means the trigonometric integrals, okay. So trigonometric integrals. So before introduce this, I first introduce some formulas, okay, some formulas. So here means some trigonometric formulas, okay. Trigonometric formulas. So here the first, okay. So the first is sin x squared plus cosine x squared equal to what?
1.
Equal to 1. Okay. So the first formula. So the second formula. Okay. So the second formula means the second x squared. Okay. Second x squared. Second x actually is what? Second x actually is 1 by what? 1 by cosine, yeah? So here should be 1 squared by cosine x squared, okay? So here 1 squared actually is 1, so we can divide this 1 by sine squared plus cosine squared, okay? So here actually means the sine squared plus cosine x squared by cosine x squared, okay? So the first here, sine squared by cosine squared actually is what? Tangent squared, yeah? So and cosine squared by cosine squared is what? 1, yeah? So here we have this equal to tangent x squared plus 1, okay? So here is second square equal to tangent square plus 1, okay? Second square equal to tangent square plus 1. So this is the second, okay? So the third actually is the cosecant x square, okay? So cosecant actually is what's the definition of cosecant? Cosecant actually is 1 by sine, yeah? So here should be 1 square by sine square, okay? So it's the same. We write 1 by sine square plus cosine square. So this is actually equal to sine x square plus cosine x square by sine x square, okay? So here first, okay, cosine square by sine square is what? Cotangent square, yeah? So here should be cotangent x square. And the sine square by sine square, so here is 1, yeah? So here means cosecant square equal to cotangent square plus 1, okay? Plus 1. So this is the third formula, okay? And now, for the fourth formula actually is, we have sine x plus y, okay? Sine x plus y, this equal to what? Sine x plus y, okay? This equal to sine x times cosine y plus cosine x times sine y, yeah? Sine x cosine y plus cosine x sine y, okay? So this is the first, okay? This is the first. Oh, this is number 4. So and number 5, okay? So number 5 actually is sine x minus y, okay? Sine x minus y actually equal to sine x cosine y minus, okay? Minus what? Minus cosine x sine y, okay? Sine y. So this is number 5, okay? So actually from number 4 and number 5, we can deduce another formula, okay? So here, for the first, we let y equal to x. Okay, for the number 4, okay, for the number 4 formula, we let y equal to x. So here we letting y equal to x. We letting y equal to x. So here actually the left hand side actually is x plus x. So the left hand side actually is sin 2x, yeah?
Yes.
So here is sin 2x. Sin 2x, the left hand side here is y equal to x. So sin x, cosine x, plus cosine x, sin x. So actually the right hand side actually is what? It's 2 sin x, cosine x. Yeah? So here we can obtain this formula, okay? We can obtain this formula. So go on, okay? So number 4 and number 5, okay? We add the left hand side, and so the summation of the left hand side equal to the summation of the right hand side, okay? So from here we can see the summation of left hand side actually is what? The summation of left hand side actually is sin x plus y plus sin x minus 1, yeah?
Yes.
So the summation of the right hand side is what? So here sin x cosine y, sin x cosine y. So the summation of these two terms actually is 2 equal to 2 sin x cosine y. Yeah. And here is cosine x sin y, and here is cosine x sin y. Here is plus, here is minus. So the summation of these two terms actually is 0. Yeah. Yes.
Yes.
Okay, so it's 0, so the result we can obtain this formula, okay? This formula, so here means that if we divide the 2 on both sides, okay? So we can obtain sin x cosine y, okay? Sin x cosine y equal to 1/2. Here should be sin x plus y plus sin x minus 1. Okay, sin x minus 1. So now we can obtain the left hand side. Okay, the left hand side actually is a product. Yeah, it's a product, but the right hand side actually is a summation. Okay, a summation. So here this we use this formula. Okay. We can transfer a product of sin cosine into the summation of sin, okay? The summation of sin, okay? So this is here is number 5, and now go on for number 6. Number 6, okay? So number 6 actually is cosine x plus 1, okay? Cosine x plus 1. Cosine x plus 1 actually equal to what?
Cos x plus y.
Actually equal to cosine x cosine y minus sin x sin y, yeah? So here number 6, okay, and number 7 actually is cosine x minus 1, okay. Cosine x minus 1 actually equal to what? Equal to cosine x cosine y plus sin x sin y, okay, sin x sin y. So here, okay, the same for number 6, okay. For number 6, we let x or y equal to x. We let y equal to x. So here we can obtain the number 8. So here means letting letting y equal to x in number 6. Okay, in number 6. So here is x, let y equal to x. So x plus x. So here should be cosine 2x. Okay, here is cosine 2x. So here. So here should be cosine 2x. Cosine 2x is equal to what? Here y equal to x. So here is cosine x times cosine x. So here should be cosine x squared, yeah? So here is cosine x squared. And here is y equal to x. So sin x times sin x. So here is sin x squared, okay? So here we can obtain the first cosine 2x equal to cosine x squared minus sin x squared, okay? Sin x squared. So here, from here, actually we can write it again, okay? Cosine x squared, actually we use this formula. Cosine x squared actually equal to 1 minus sin x squared, yeah? So here, cosine x squared actually is 1 minus sin squared. So 1 minus sin squared, here is 1 minus sin squared minus sin squared. So here is 1 minus 2 sin x squared, yeah?
Yeah.
It's the same, okay? Actually, it's sin squared. Sin squared actually equal to 1 minus cosine squared, yeah? So here sin squared actually equal to 1 minus cosine squared. So here is cosine squared minus 1 minus cosine squared. Actually, so here equal to what? Equal to 2 cosine x squared minus 1. Okay, minus 1. So here, this is number 8. Okay, this is number 8. So number 8.
Now she explain number 8 again.
So we can actually here let y equal to x. Y equal to x. So here is cosine x plus x. So cosine 2x. So let y equal to x. So cosine x times cosine x. Cosine x squared. Sin x times sin x. So sin squared. Cosine squared minus sin squared. Cosine squared actually from here, cosine squared equal to 1 minus sin squared. So here is 1 minus sin squared minus sin squared. 1 minus 2 sin squared. It's the same, okay? We learn sin squared actually equal to 1 minus cosine squared. So here is 1 minus cosine squared. So here equal to 2 cosine squared minus 1. Here is number 8. So from number 8. So here, from number 8, actually we can obtain what? So from here we can obtain sin x squared, okay? Sin x squared actually equal to what? So here, sin squared, 2 sin squared actually equal to 1 minus cosine 2x, yeah? Now we can see here, cosine 2x actually equal to 1 minus 2 sin x squared, yeah? Number 8, yeah?
Yes.
Cosine 2x equal to 1 minus 2 sin squared.
Yes.
So from here we have what? So from here we have sin x squared actually equal to what? 1 minus cosine 2x by 2, yeah?
Yes.
Yeah? So here sin squared actually is 1 minus cosine 2x by 2, okay, by 2. So this is sin squared, okay, it's the same. So cosine squared actually equal to what? So now we can see cosine 2x equal to 2 cosine squared minus 1, yeah?
Yes.
So here, from here we can have v plus 1 on both sides and divided 2. divided 2. So we can obtain cosine square actually is
Cos 2 squared.
1 plus cosine 2x by 2. Yeah?
Yes.
So this is number 9. Okay, so this is number 9. And now for number 10. Okay, so number 10 here, the same. Okay, so for number 6 and number 7, for number 6 and number 7, we summation the left hand side equal to the summation of right hand side. Okay, the
Yes.
summation of left hand side equal to summation of right hand side. So the summation of left hand side actually is what? Is cosine x plus y plus cosine x minus y. Okay, so this is the summation of left hand side. So the summation of right hand side actually is what? Here is cosine x, cosine y, here is cosine x, cosine y. So summation of these two terms actually is 2 cosine x, cosine y. Yeah? And here is sin x, sin y, sin x, sin y. Here is minus, here is plus. So summation this part is 0. Yeah? So here is 0, here is 0. Okay? Here is 0. So from here we can obtain the cosine x, cosine y actually equal to 1/2 cosine x plus y and plus cosine x minus 1. Okay, cosine x minus 1. So this is the number 10. Okay, number 10. So here number 10 means the same. Okay, here the left hand side is a product of cosine, cosine. The right hand side is a summation. Okay, is a summation. So we use the formula, number 10 formula. Okay, we can transform a product of cosine, cosine into the summation of cosine, cosine. Okay, so this is number 10, and actually here we can obtain here now. We can see here is sine, cosine. Here is cosine, cosine. So here we have what? We sine, sine. So here, what about sine, sine? So sine, sine actually is the same. Okay. For the number 6 and the number 7, the difference of left hand side actually equal to the difference of right hand side. Yeah. So the difference of left hand side. So the difference of left hand side actually is cosine x minus y minus cosine x plus y. Okay. So here this is the difference of left hand side. Okay. So the difference of right hand side. So the difference of these two terms is what? 0. Yeah. And the difference of these two terms. Sin x, sin y minus sin x, sin y. Yeah. So the difference of right hand side actually is 2 sin x, sin y. Yeah. So from here, this tells us what? Sin x times sin y. So this tells us sin x, sin y. Okay, sin x, sin y equals to 1/2 cosine x minus y minus cosine x plus 1. Okay, so this is the number 11. Okay, so this is number 11. Yeah.
All the things I'm just memorized.
What?
Teachers are still doing advanced mathematics, like as courses.
Yeah.
Mathematics. Courses doing mathematics.
Oh, I know. Actually, I use this minus this. Okay, this minus this. So equal to this minus this, and this sin y, sin x, sin y minus this. Okay. So now, for this 11, okay, for this 11 formula, okay, I hope that you can keep it in mind, okay? Keep it in mind.
Nah,
Oh
see,
my God.
no.
It is so refined, but it is very
I
hard
just keep it in mind.
to realize.
Let's do a lot of examples.
If you can just keep it in mind, Loshi, a lot of examples. You should do a lot of examples.
You get from here
We
and
do a lot
there.
of examples.
So it's so hard for you to remember.
Yeah.
But actually, so actually it doesn't matter, okay? But if you cannot remember it, okay? So you cannot solve the problem in the examination, okay? So, okay, that's it. Now, I will introduce four reduction formula, okay?
Oh, you're still
How many
using
formula
formulas.
have?
For reduction formula, okay? Four reduction formulas, okay? Four reduction formulas. So the first one, okay? So the first one means the antiderivative of sin x to the nth power dx, okay? Sin x to the nth power dx. The antiderivative of sin x to the nth power, okay? To the nth power. So here for this one, we will use the integration by parts, okay? So integration by parts. So here actually first equal to what? Here we write the sin x to the nth power by two parts. The first part is sin x to the n minus 1 power. The second is sin x to the 1th power and dx. We write it in this form, okay? We write it in this form. And so here we let this part to u. This part is u, and this part we let it dv, okay? So dv here means dv, okay? So here dv equal to sin x dx. So here means dv dx equal to sin x. So for which function derivative equal to sin x? Cosine x minus cosine x. Yeah. So here actually means b equal to minus cosine x. Okay. So here actually equal to sin x to n minus 1 power, and here is d minus cosine x. Okay. So we write it in this form. Okay, this form. Here is u, here is v, okay? Here is u, here is v. So we use this formula, u dv equal to u times v minus v du, okay? So here is u duv, so here equal to sin x n minus 1 power uv times cosine x. So here is a minus, okay, here is minus. And minus v du, okay? V is minus cosine x. Du, u is sin x to n minus 1 power, okay? So here equal to here. Here is minus, minus. Minus, minus, so here is plus, okay? So here is plus. Now we need to find sin d. D sin x to n minus 1 power equal to what? So first, d here, d sin x to n minus 1 power dx equal to what? Means the derivative of sin x n minus 1 power. This function, derivative equal to what?
Cos x n minus 1.
Is n minus 1
Cos x.
sin x n minus 2 power, yeah? And the times sin x derivative, yeah? Sin x derivative is what? Cosine x, yeah? So here means this function, okay? So here means d sin x n minus 1 power actually equal to n minus 1 sin x n minus 2 power cosine x, okay? Cosine x. So here equal to what? So here equal to minus sin x n minus 1 power. Here is cosine x and plus. Here is cosine x times this part, okay? So here is n minus 1. N minus 1 is a constant, can move through the integral sign. So here is n minus 1. Here is what? So here is sin x n minus 2 power. Here is cosine times cosine. So here is cosine x squared dx. Okay, so here we can open this formula. So here cosine x squared actually is what? Cosine x squared actually is 1 minus sin squared, yeah? So here we can write it in this actually equal to minus sin x n minus 1 power cosine x, here plus n minus 1. Here should be sin x n minus 2 power. Here is 1 minus sin x squared dx. Yeah? So here now we can see here is 1 minus sin x squared. So we can go on. So actually here is minus sin x n minus 1 power. Here is cosine x. So here is plus n minus 1. Here is what? Here's the first term, okay? Sin x n minus 2 power times 1. So here is sin x n minus 2 power dx. The second term, okay, minus n minus 1. Here is what? Sin x n minus 2 power times sin x squared is what? Sin x n minus 2 power times sin x squared equal to sin x to the nth power, yeah? So here is sin x to the nth power dx. So the left hand side is what? The left hand side is the antiderivative of sin x nth power, yeah? So for this one, so on the both sides, okay, on the both sides, we add this term, okay, we add this term. We add this term, so from here we have what? So this term, okay, this term, we move it on the left hand side. On the left hand side, so this here is the same. Here is n minus 1, here is 1. 1 plus n minus 1. So here is n, yeah? N times this part, this equal to here, yeah? Yeah? So now, from here, we divided n on both sides. We divided n on both sides. So here we have this is my n divided n. So from here, we open the first reduction formula, okay? The first reduction formula, so here means the antiderivative of sin x to the nth power dx equal to what? So equal to minus sin x n minus 1 power minus sin x n minus 1 power times cosine x by n. And here plus n minus 1 by n. Here is the antiderivative of sin x n minus 2 power, n minus 2 power, okay? So this is the first, okay, so this is the first reduction formula, okay? Now we have 10 minutes rest, okay? I will rest 10 minutes.
Exactly. So is eating our time. It's our time. You see, don't even reach 10 minutes. All this just to find one formula. Should I pause?